how do you see rocketry evolving in the future?
For us, on our scale, it's very important that we keep on pushing our technological level overall of the system design that we have towards industry standards. We've said that a bunch of times again now, but it's really important for us to say that we can develop this difficult technologies, so to say, and prepare our students for the time when they enter industry, so they already have hands-on knowledge in these systems. So for example, a switch to a pump fed cycle is really essential, but it's also the part of us working with a high degree of carbon fiber in the system, because those lightweight structures will find their way in the aerospace sector, or will expand in the aerospace sector. Then we are also working on type 5 pressure vessels, for example, which is also going to, in the end, optimize the mass of our system. So there's a bunch of technological developments going on in our team that we are trying to push to get in the rocket. And the competitions are always super important for that, because it gives us a framework of trying out these technologies and having again a framework of development. So we can say that from competition to competition, we want to improve our system and try to implement a new set of technologies that will eventually help us to design a rocket that is comparable to industry standards. So this is the direction that we want to go in, generally speaking, with rocketry, or with our student group.
We talked already a lot about what we want to implement in future designs, but I think it's already quite a deal what we implemented currently into the system. So for example, speaking of liquid oxygen as oxidizer is already a quite huge deal, because touching on safety regulations again with this medium is quite not that easy to handle during testing operations that we frequently do here at university. And also the engine itself being regeneratively cooled by our fuel. And also, what we discovered is that we are one of the few teams that are actually capable of producing our own carbon fiber parts and glass fiber parts. So we are also really, really happy about this, that we are able to optimize our carbon fiber skin segments and our nose cone itself in shape and material layup, basically. So we are constantly pushing on the carbon fiber development as well, making the structure even lighter. And we are also running a load bearing skin in our rocket, which I haven't seen much in the competition so far. So normally, or usually, teams run a lot of internal load structures with an aero cover around the whole rocket. And we try to make it work without the internal structure to get rid of the extra weight, basically. Also all of the valve development that we are doing. And as Matthias already said, the Type 5 tank development is also a really huge deal we are currently aiming for. But we in rocketry, people are always speaking about the propulsion system and the fluid system itself, forgetting about the electronics. So maybe you can say a few words what you already produced here with your flight computer, because I don't understand much about it, but I know how impressive it is. That's why I want you to talk about it.
The decision to build our own flight computer was made in 2021. It took us about 2 years to arrive at what we flew at EUROC. Before, we were using a commercial off-the-shelf part that I'm told was worth in the 5 digits somewhere, the lower 5 digits. There were lots of problems, and they basically couldn't get it to work. And at some point, it was just decided that we're going to do it ourselves. And then basically we went through 4 iterations, and we arrived at a working system that, I'm pretty confident that it would have flown at EUROC. There were issues, but there are issues with it. But I think now the focus is to make it robust. So basically what it does, the primary flight computer, is it reads in values from sensors all over the rocket. It estimates the state of the rocket. It detects launch, apogee, fires recovery with pyrotechnics. And it also, of course, one of the most important tasks is it controls the valves on the rocket. So it actually controls the flow of oxygen and propellant. The software is what is basically the brain of the operation. And it sends down telemetry. We get a nice high-speed downlink of data from there, and also it does some local logging as a backup. And all of this has been developed by us students in the span of 2 years. I think it's a really impressive feat, and I'm really proud of my team that of this development.
Besides studying.
Besides studying, and in some cases also working.
Yeah, true.
How much of your rockets do you build yourself, and how much do you outsource to sponsors?
That's something we are also quite proud of, that we produce a lot of rocket parts ourselves. So yeah, from the outer shape of the rocket, most of the parts that you can see are related to aerostructures. Obviously, so everything you see on the outside of the rocket is produced by us here at university, by our own students. That's mostly carbon fiber parts, but also glass fiber parts from the outside. Inside we have aluminum connector rings that connect each segments. These were partly produced by ourselves, but due to the high number of rings we needed, we decided to have them made by a manufacturer in the end. But yeah, we produced some prototypes ourselves, and they work quite fine. I think we even used one in the rocket in the end. It was just the sheer amount of parts that we couldn't handle in this case. So yeah, we can do complicated CNC milled aluminum and also other material parts. We have I would say one really skilled member in the team that is doing most of our parts. Shout out to Andrea. I think you met him at the competition. He was the one that was milling a connector last minute on the back of our pickup truck with our own mill. Funnily enough, he was able at the competition to make a adapter part where we haven't even had the thread cutter with us. So he basically made his own thread cutter out of a screw. So yeah, that's his that's his special skill, I would say, and we are really happy to have him in the team. And yeah, he's producing most of our parts in this sense. The only thing he's not involved in is the carbon fiber stuff yet, but he's touching on that right now. And yeah, also you've seen maybe our chamber, our region chamber at the competition. Of course, after it comes out of the 3D printer, it needs to be post-processed, and it's Inconel. And everyone that knows about Inconel material properties knows that it's not that easy material to machine. That was no big deal for Andrea. He post-processed our chamber really accurately. We had sealing surfaces on there, and yeah, everything worked out fine after he processed them. Also, Inconel is no issue for us right now. Of course, there's some 3D printed parts in the rocket as well, but mostly some holding structures for some fluid components. And yeah, I think that's about it, about the manufacturing stuff. Yeah, to put it like this, basically all of or most of the parts that you can see are done by ourselves. Also, the whole electronics pick and place. We ordered the circuit boards and the raw components and put them together ourselves. So the hands-on learning opportunities in the team are quite huge. You can touch on various manufacturing tasks and expand your knowledge beyond the pure design of a part, but also dive deep into the manufacturing tasks themselves.